How are you guys? Today we are going to prove that 2 to the power n is less than n factorial for all n greater than or equal to 4. For all n greater than or equal to 4. So for our initial stage, since n is greater than or equal to 4, it means we are going to show for n equals to 4. That is the initial value. So when n equals to 4, left hand side of the inequality equals to 2 to the power 4, which is 16. And the right hand side equals to 4 factorial, which is 24. So you can see that the left hand side is less than the right hand side. Thus, 2 to the power 4 is less than 4 factorial. Therefore, the statement is true for n equals to 4. So since we have managed to show that the statement is true for n equals to 4, we move to the inductive assumption. We assume that the statement is true for n equals to k. So when n equals to k, assume 2 to the power k is less than k factorial for all k greater than or equal to 4. So this is the inductive assumption. Then after the inductive assumption, we now prove for n equals to k plus 1. So when n equals to k plus 1, so we wish to show that 2 to the power, when there is n, we now put k plus 1. So 2 to the power k plus 1 is less than k plus 1 factorial. It's less than k plus 1 factorial. So we take we start from the left hand side. 2 to the power k plus 1 equals to 2 to the power k times 2. You can see that this is less than 2 to the power k times k, since k is greater than or equal to 4. So it means k is greater than 2. Since k is greater than or equal to 4, it means this implies k is greater than 2. That is how we end up with that inequality. Again, this is less than k factorial times k. Since 2 to the power k is less than k factorial. This is by the inductive assumption. So we now have k factorial times k. Again, this is less than k factorial times k plus 1. This is clear since k is less than k plus 1. So where there is k, we replaced with k plus 1. But 5, for example, 5 times 4 factorial equals to 5 factorial. So here we have k plus 1 times k factorial. This is equals to k plus 1 factorial. This is equals to k plus 1 factorial. So clearly, we have 2 to the power k plus 1 less than k plus 1 factorial. So we have managed to show that 2 to the power k plus 1 is less than k plus 1 factorial as desired. So after this stage, then we make our conclusion. Since the statement let me do this here. Since the statement is true for n equals to 4, n equals to k, and n equals to k plus 1, the statement is true for all n, an element of natural numbers, and n greater than or equal to 4 is desired. Thank you very much, guys. This is how we prove an inequality. So please remember to subscribe and like, and also share the link to the video. And you can also give recommendations, or if you have any suggestions, please feel free to comment in the comment section. Thank you.